Hi guys, it's Miss Hubbell. Today we're going to be working on topic 14, lesson 3. Today we're doing patterns in repeating shapes. Our learning target today is going to be, I can use a rule to predict a number or a shape in a pattern. All right, let's take a look at our solve and share problem today. It says, the rule for the repeating pattern below is square, triangle. What will the 37th shape in the pattern be? And then explain. So this is a two-part problem. 1, what's the 37th shape? And 2, explain how we know. Solve this problem any way we choose. We've got only 2 shapes in our pattern. So the pattern is square, triangle, square, triangle, square, triangle. Now there's 2 ways we can solve these pattern problems. The first way we can solve any of these pattern problems is by physically counting it out. It's kind of like the foolproof, easy way to get the job done. The other way might be a little bit faster, but it might be a little more difficult. And that's using division and reasoning. Meaning like we're using our logic to figure out the answer. So let's try counting it, and then we'll try using division and reasoning. So I can see here that I want the 37th shape. So I'm going to start counting, and I'm going to say the first shape is a square, second shape is a triangle. Square, triangle, 5, 6. It would start over. So number 7, right? The 7th shape would be a square. That would be 7. 8 would be a triangle. 9, 10, 11, 12. It makes sense that 12 would be in the same position as 6 because 6 and 12 is a multiple of 6. And then I would start over and I would say 13, 14, 15, 16, 17, 18. 18 is also a multiple of 6. 19, 20, 21, 22, 23, 24. 24 is also a multiple of 6. 25, 26, 27, 28, 29, 30. That's a multiple of 6. 31, 32, 33, 34, 35, 36. That's also a multiple of 6. So I want the 37th shape. Well, if the 36th shape is a triangle, I would start over, and 37 would be a square. So what will the 37th shape be? It will be a square. Explain. Well, my explanation, I'm going to have to erase some of this so we can see our answer, right? My explanation in this case is going to be that I counted out the pattern all the way to 37. Did it the long way, right? Let's try it another way. Let's try division. When we do a pattern shape like this, we can use dividing by the number of shapes in the pattern. So we said that there were only 2 shapes in the pattern, right? Square, triangle. So it's a pattern of 2 shapes. So I can take 37 and I can divide it by the 2 shapes. Does 2 go into 3? Yes. 1 time. 1 times 2 is 2. I can subtract. I'm going to bring down my 7. 2 goes into 17 8 times. And then 8 times 2 is 16 down here. I can subtract, and I'm going to have a remainder of 1. So when I divide my 37 shapes by 2 in each pattern, I get 18 remainder 1. Well, what does that mean? The 18 means that I can make 18 complete sets of this pattern, or I can make 18 groups of square, triangle. The remainder 1 means that there's 1 more after that. So 18 groups of the pattern and 1 more. This is my remainder of 1. It lands on a square. So that's how I can use division and reasoning. Another thing is we could actually use a feature of the pattern in this case. So we noticed that when we looked at this pattern, what were all of the squares? They were all odd numbers. What were all the triangles? They were all even numbers. Well, 37 is an odd number. Well, all the odd numbers were squares. I can use that feature of the pattern to determine that 37 will also be a square. So let's say I had to explain these other two ways. I had to, because I do have to explain, right? If I wanted to explain the division way, I could say I divided 37 by two shapes in the pattern. Remainder 1 means it's the first shape in the pattern. Remainder 1, I go to the 1, the first shape is a square. If I wanted to explain the odd, I could say I could use a feature of the pattern, like all the squares were odd, to figure out that 37 would also be a square because 37 is odd. So that's just some different ways we can figure it out, different ways we can explain it. I would say definitely counting it out is the easiest way. But if you're feeling pretty mathy today, you might want to try using a little division and reasoning. You might be able to come to the answer more quickly that way. Okay, it says, after the 37th shape is placed, that was the one we just figured out, it was a square, right? How many triangles are in the pattern? This, again, we're going to have to use some division because we're trying to figure out how many times that pattern repeated itself. Well, if there are 37 shapes and there's only 2 shapes in the pattern, we came up with the fact that there were 18 total groups of the shape, and there was a remainder of 1 shape left over. So if I have 18 groups of the pattern, so I have 18 sets of square triangle, 18 sets like that, how many triangles are there? Well, there are 18 in that set of 18 patterns. But remember, we have 1 more left over. Now, this was a square triangle pattern. So the 1 left over was a square. Well, we're looking for triangles. So we don't need to add on that 1 remaining. We only had 18 triangles in our pattern because the pattern repeated itself 18 times. Let's keep trucking along. Oh, and I want to point something else out too. Let's say you were just trying to count. Could I go back here and could I say, could I count each of these shapes and figure out if how many triangles there were? Sure, I could draw it out and count the number of triangles if I wanted to be very concrete and see it that way. That would work. Next comes your visual learning video, so make sure you use your Pearson visual learning video to work on this page in your book. Let's take a look at the convince me at the bottom of the page. It says, suppose the rule is square triangle, square trapezoid. Okay, we can do that. Let me underline the rule. And it says, what is the 26th shape in the pattern? Describe features of the repeating pattern. Be precise. So we have 2 parts. What's the 26th shape? Describe features in the pattern. So let's do it. I think I'd probably like to start by just drawing out the pattern. That seems like the good way to start. Square triangle, square trapezoid. Trapezoid's kind of like a triangle with the top snipped off, right? Okay. It's not a great trapezoid, but they did the best they could. Let's see. We have our repeating pattern. How many shapes are in our repeating pattern? There are 4 shapes to our pattern. Now I could do this. I could just sit here, let me use a different color, and I could count out to 26. So I could say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. I landed on the triangle. So what is the 26th shape in my pattern? It's a triangle. Now, there are other ways other than counting it out that we can figure this out. Let's try division. Let's look at 26 shapes. Let's divide it by there are 4 shapes in the pattern. Let's see how many total groups of this pattern we can make. Does 4 go into 2? No, that's too small. Does 4 go into 26? Yes, it does. How many times does 4 go into 26? It goes in 6 times. I could make 6 total groups of this pattern. 6 times 4 is 24. I can subtract. My remainder is 2. That means I made 6 whole sets of this pattern, and then I had to start over with the 2 extras. 1, 2. 2 is where I landed on my triangle. So instead of counting all the way up to 26, I did the division part, and then I only had to count up to my remainder of 2. Both ways, I got a triangle. You might have also noticed that the trapezoid, the last shape, was always a multiple of 4. So 4, 8, 12, 16, 20, 24, 25, 26. Now, if what I just did felt confusing, the division part or thinking about multiples, if the division and reasoning feels confusing, you can always physically count it out. You absolutely can do that. Now, let's describe features of the pattern, because that was the second part of our question, right? Let's get rid of some of this mess. Well, one feature is how many parts are there to the pattern? We could say there are 4 parts to the pattern. There's no odd or even here. There's no increasing or decreasing because these are shape patterns, not number patterns. We have to get pretty creative. What's another thing we could say? What did we say about that trapezoid? We found that because there are 4 shapes in the pattern, and the trapezoid is the last final shape, the trapezoid is always a multiple of 4. There are 4 shapes and it's the last one, so there you go. So when I counted 1, 2, 3, 4, the trapezoid was a 4. 5, 6, 7, 8, the trapezoid was a number 8. 9, 10, 11, 12, trapezoid was number 12. They're always a multiple of 4. That's another good feature. And they wanted features. Well, I've got 2 features. 4 parts in the pattern. Trapezoid is always a multiple of 4. Or I could say, yeah, that works. Let's keep rolling. Let's look at the top of the page here. They have another example for us to look at. So let's do that. It says, write the next 3 numbers in the repeating pattern. Then name the 100th number in the pattern. They gave us our rule. Write the next 3 numbers. That was the first thing we had to do. And then name the 100th number. That was the second thing we had to do. They gave us the rule. The rule was 1, 3, 5, 7. So this is a number pattern. But it's not a number pattern that follows a repeating rule like add 2 or multiply by 3. This one's just numbers in a repeating fashion. So we had 1, 3, 5, 7. 1, 3, 5, 7. 1, 3, 5, 7. You might find that boxing in the numbers make things easier for you. 1, 3, 5, 7. So they filled in the next 3 were 1, 3, and 5. What would be the next one? Well, it would be 7, wouldn't it? They said there are 4 items in the repeating pattern. Remember, 1, 3, 4, 7. To find the 100th number, We divide by the number of shapes or numbers in the pattern. So we're going to do, there were 4 parts to the pattern. We're going to divide by 4. So they actually took 100 here and they divided it by 4. When they divided 100 by 4, they got 25. That means that this pattern, 1357, can repeat 25 times. Are there any left over? No, there's none left over. So when they get to 100 and they repeat this 25 times, whatever's the last number, that's going to be what's in the 100th position. So they knew that the 100th position would be 7. It would be 7. So they used a division there. That would be one where could I count it out to 100? Yes, I could count out these numbers to 100. Would I want to? Not really, because that's really high and it would take a long time. I think I'd really rather just divide and use reasoning. Could I count to 100? Yes, I could. I could do that. Let's look at the guided practice together. It says, in the triangle, square, trapezoid example on the previous page, what will be the 48th shape, the 50th shape? Explain. They want us to do 3 things. What's the 48th shape? What's the 50th shape? And they want us to explain. Well, let's look at our pattern. Triangle, square, trapezoid. How many parts are there to my pattern? There are 3 parts. Could I sit here and say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, I could do that all the way up to 48. I could do it all the way up to 50. And then I could explain and say that I counted the shapes all the way up to 48 and then 50. And that's how I figured out what they were. That's a good explanation. It's probably the longer way to do it though, right? So let's figure this out. Let's try by using division. They said 48 shape, the 48th shape, let's divide it by the 3 parts to the shape. 3 goes into 4 one time. 1 times 3 is 3. Let's subtract. Bring down the 8. 3 goes into 18. Yes, it does. Exactly 6 times. 6 times 3 is 18. I'm not going to have any left over. So the 48th shape, I can make this pattern exactly 16 times. Well, if I'm making exactly this pattern 16 times with none left over, what is the last shape? Because that's the 48th shape. The 48th shape is a trapezoid. Because I'm making this exact pattern 16 times, the last thing is going to be the trapezoid. Now we have to figure out the 50th shape, right? Okay, let's use our division again. Could I count it out? Yes. I don't want to. I think that takes too long. I'm going to use division. 50 shapes, and the pattern has 3 parts to it. 3 goes into 5 one time. 1 times 3 is 3. I have to subtract. 5 minus 3 is 2. Bring down. How many times does 3 go into 20? Well, it goes in 6 times. Again, right? 6 times 3 is 18. And 20 minus 18 is a remainder of 2. So this time I can make the pattern 16 times, but then there's 2 left over. So 16 times, then remainder 1, remainder 2. This time, the 50th shape is actually the 50th shape is the square, the middle shape, right? And then it says explain. Well, your explanation, your explanation is going to depend on what you did. Did you count it out? If you counted it out, your explanation is I counted all the shapes until I got to 48 and 50. If you divided like me, your explanation is I divided the total number by the number of shapes in the pattern. The remainder told me which shape I needed to choose. I don't have room to write it. You're going to have to write it for me. You might need to pause your video and write it down for me, okay? All right, let's look at number 2. They said, what is the 20th shape? The rule is triangle, circle, circle. There's my rule, and my question is, what is the 20th shape? 20 is not that high of a number. It honestly might be easier just to count this out myself, right? So I would say the first shape, second shape, third shape, fourth, fifth, sixth, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. The 20th shape is a circle. I figured it by counting it out. Is there another way to do this? Well, of course there is. We could divide, right? So let's try that over here on the side. The 20th shape, how many parts were there in the pattern? The rule had 3 shapes, triangle, circle, circle. So I'm going to divide this by 3. 3 goes into 20 once. 1 times 3 is, oh, I'm sorry. Oh, gosh. This Hubbell made a snafu. 3 doesn't go into 2. 3 goes into 20, though. It goes in 6 times. 3 times 6 is 18. Subtract, and I get 2. Remainder of 2. So I could make this pattern 6 times, and then 1, remainder 2. I still land on a circle. So I can either divide and use reasoning, or I could physically count it out like I did at first. Let's look at number 3. Write the next 3 numbers. That's the first thing I have to do. The rule is 9, 2, 7, 6. I'm going to box these in. It makes it easier for me. 9, 2, 7, 6. 9, 2, 7, 6. 9, 2, 7. And there's no more blank. They only wanted 3, but the last one would be 6 in that pattern, right? So that one wasn't too difficult at all. Yay. Let's look at another. Today for independent practice, you are going to be doing the evens only, right? Evens only. So you're going to want to go through there and mark out the ones you don't have to do. You don't have to do these odd ones. You're going to do 4, 6, and 8 on this page. You're going to continue those patterns. Those don't look too bad. Then on the back, when you continue the independent practice, you're still doing evens only. You'll do 10, 12, and 14. You don't need to do the evens. You'll need to do 16 and 18, right? You don't have to do the odds. I think I said something wrong, one of my word things. We're only doing the evens, not the odds. Only the evens, not the odds. Want to make sure that there's no confusion there, right? All right, guys, I know that you can do this. Good luck. You'll be excellent. I will Zoom a meeting to do these independent problems. So if you'd like to join me for Zoom today, you certainly can, and we can work those independent, even problems together in a group. Okay?